Welcome back to mock examination multiple choice section. We'll continue with question 4. If hx equals the third root of x plus 5 squared, express h as composition of two functions f and g such that hx equals f of gx. So in this case, as you can see, we have a radical in the composition, and when you take a quick look at all the options, radicals appear nowhere. The reason behind this is because very often radical terms are hidden into exponential terms with exponents in rational form. So recall the formula. The nth root of some term a would be equal to a to the power of 1 over n. So the index of the radical becomes the denominator of the exponent. So in order to best approach this answer, what you would do is try to create the composition of f of g of x for each option. Now, if you were thinking of decomposing the function and try to match with either option, that can be a little bit more difficult because you can decompose a function in many different ways. So the way you would decompose it is not necessarily going to be one of the 5 options here. So let's start off with option A. So f of gx means that instead of x for function f, we're going to have the function g of x. So here is the function f of x. So g of x is 1/3, which means that would be f at 1/3. Now, if you substitute x by 1/3 in function f, then you would get a constant number. And the composition is not a constant number, so therefore we're going to say that option A is not possible. So option B, we have f of gx, which means we have f. G of x is x to the power of 2 over 3. So that means that wherever you see x in function f, you replace it by x to the power of 2 over 3, which makes the composition x to the power of 2 over 3 plus 5, which obviously is not the same as the function h of x, so it's not possible. Question option C, I would say, we have f of gx again, which equals f at x plus 5. And that would be equal to, again, wherever you see x in the function f, we'll replace it by x plus 5. So x, or x plus 5, will be brought to the power of 2 over 3. So bring it to the power of 2 over 3. So notice that here we have a denominator of 3, which means that we can convert this into a radical with index 3. So that means the third root of x plus 5 squared. And this seems to perfectly match the equation of h of x. Therefore, we'll say that option C is the correct answer. Now, in the meantime, try to check the rest of the options. Sometimes we may have a sense that this is the correct answer, but there might be slight differences that can be a little bit deceiving. So if you look at f of x equals 1/3, there is no x to substitute in here, so D doesn't work. And f of x equals x squared plus 10x plus 25 is if substituting x to the power of 2 over 3 for every x in f, then you won't get the same equation. So we are going to say goodbye to this question very happily, because I think that we have chosen the right option there. Option C is the correct answer. Question 5, we have f of x equals 1/2 x, g of x equals 3/10 x. We need to find g of f of x, and we have 5 different options here. So in this case, I would start off by finding g of f of x, and then trying to match my answer with either option. Because there is only one way of finding g of f of x, and that's the reason why you start from the question here. So g of f of x means that we are finding g at f of x, or g at 1 over 2 to the power of x. Let me write this a little bit better. So wherever you see x in function g, we are replacing this by 1 over 2 to the power of x. So function g starts with a 3 and then 10x. So we have 3, we have 10, and now it's time to write x, which we are replacing by 1 over 2 to the power of x. Now let's revisit all the options. So this is what we're looking for. So 3, 10. So 3, 10, oh, this is squared, so this doesn't work. Next we have 3 10x 1 over 2 to the power of x. This is very deceiving. So for a moment I thought that this would be the option. But not, because you also have an x inside 10. So we're going to cross out option B. Option C is not possible at all. As you can see, it doesn't match with our answer. It doesn't start with a exponential function. G of x is not an exponential function, that's why. The next option is 3x times 10 to the power of 1 over 2. Now, it seems that the x that we have in here has come down here, and that is not possible. There is not a rule that guarantees that. So option D is not possible. And the last option, 310 of 1 over 2 to the power of x, seems to be our correct answer. So we'll circle this one. This would be the correct answer. Question 6. Which of the following is always true? F of g of x is g of f of x. Not always true. F of g of x equals f of x times g of x. Well, this is a composition, and this is a product of two functions, so that is not possible. F of x equals the product of the two functions. Again, this is not possible. Now, f of g inversed would be the f inverse composite g inverse. So inverse f of inverse g. We've never talked about this rule, and that doesn't work either. F of f negative 1 x equals x. So we know that when we compose a function with its own inverse, the answer is x. So this would be the correct answer, D. Question 7. Which of the following functions appear in quadrants 1 and 4 only? So this is one of those questions where you have to visit every option and check and see if they fit the description. So y equals log with base 2 of x will be the log function, okay, that will start from the right side of the y-axis and then go up. So this function appears in quadrants 1 and 4. So just 1 and 4. Now, y equals 2 to the power 2 over x is a rational function. And rational function 2 to the power 2 over x will appear in quadrants 1 and 3, because it will have the vertical asymptotes. Y equals x squared will appear in quadrants 1 and 2. And y equals 2 to the power of x will appear in quadrants 1 and 2. And y equals 2x, this is going to cross from quadrant 3 to quadrant 1. So then we have 3 to 1, we have 1 and 2, we have 1 and 3, and then we have 1 and 2. So our best option here would be option A. Question 8. For f of x equals 5 times 3 to the power x plus 2, the equation of the asymptote is, so this is an exponential function. Exponential functions have horizontal asymptotes at the vertical translation, and the horizontal asymptote in this case would be y equals 2. So visit all the options, check and see which one fits the description, and it seems that A works. So A is the correct answer. So if you were to graph this function, just so we have a better idea, so we have y equals 5 to the power 3 to the power of x. You stretch it by a factor of 5, which means that the y-intercept will move up. And then you move it 2 units up, which means that this very graph will go 2 units higher, and it will look like this. So y equals 2 would be the horizontal asymptote.